Okay, the oscillating current in an electrical circuit is given here by the equation I, which is measured in amps. I is equal to 8 sine of 60 pi t plus cosine of 120 pi t. What we want to do here is find the average current for the time interval 0 to 1/60th. So basically the average current over the first 1/60th of a second. Okay, so keyword is average. So we have the average value of a function, and I is a function of t. And so over here I have the equation for the average value of a function. It's 1 over b minus a times the integral a to b of f of x dx. And so f of x in this case is this function I. And here's our a, here's our b. So b minus a is 1 over 60, so 1 over b minus a will be 60. Okay, so when we set up our integral for the average value of this function, we will have, let's see, 1 over b minus a, which is 60, times the integral from 0 to 1/60th of 8, times the sine of 60 pi t, plus the cosine of 120 pi t, and we're integrating with respect to t, so there's a dt. Okay, so we also know, let's come over here to the right, that the integral of f plus g of x dx is equal to the integral of f of x plus the integral of g of x. So let's set this up as two separate integrals. I think that'll make things easier. We'll integrate the sine function, and then separately we'll integrate the cosine function. And so for the sine function, we have a 60 times 8, so that's 480 times the integral from 0 to 1 over 60 of the sine of 60 pi t dt. And then over here plus, we have 60 times the cosine. Okay, so we have a 60 on the outside. 60 times the integral 0 to 1/60th of the cosine of 120 pi t dt. Okay, so let's keep these separate. We'll do them one at a time. So on the right, on the left, integrate the sine function. Okay, looks like we could do a u substitution here. Let's let u equal 60 pi t. So du is equal to 60 pi dt. And we just want to substitute for dt, so let's isolate the dt. So we could say 1 over 60 pi times du is equal to dt. Okay, so this will sub in for the dt. And this will sub in for the 60 pi t. Okay, so that'll clean things up nicely. Scroll down a bit. Okay, so with our substitution, we still have the 480 on the outside. So that equals 480 times 1 over 60 pi times the integral of, it looks like it simplifies to just the sine of u du. All right, so now what about our limits of integration? Well, using this equation up here, if you plug in 0 for t, when t is equal to 0, u is equal to 0. So that will give us a lower limit of 0. And when t is equal to 1/60th, u is equal to pi. So that will give us an upper limit of pi. 60 times pi times 1 over 60 will be just pi. Okay, so, excuse me, changing our limits of integration means we don't have to back substitute and go back to t. Once you do a u substitution, if you change your limits, stick with u for the rest of the way. Okay, so 480 times 1 over 60 pi, that should give us right about 8 over pi. So we have 8 over pi times, well, the antiderivative of sine is the negative of the cosine function, and we evaluate that from 0 to pi. Okay, so we have 8 over pi times the negative cosine of pi, well, that's negative 1, so that's a 1, minus negative cosine of 0, so that should be 1 minus a minus 1, or 1 plus 1, which is 2. So we have 8 over pi times 2, or 16 over pi. Okay, let's do that. So remember, that's half of our problem. So now we'll do the 60 cosine of 120 pi t. Okay, so same thing. We'll do a little u substitution here. Let's say u is equal to 120 pi t. So du is equal to 120 pi times dt. And again, we just want to substitute for the dt, so let's isolate the dt down here. We could say 1 over 120 pi times du is equal to dt. So we'll plug this into our integral for dt. We'll plug this into our integral for, oh, that's not what I meant. We will plug this. U, sorry about that. U is 120 pi t. Du is 120 pi dt. And we will be plugging this u in for the 120 pi t. Okay, so those two things go into our integral. And let's see what we get here. We have 60 times, let's bring the 1 over 120 pi, that's a constant, so we'll bring that out front. 1 over 120 pi times the integral of cosine of u du. And now let's see what we have for our limits of integration. Again, we'll use this equation. When t is equal to 0, u is equal to 0, because 100 times 120 times pi times 0 is still 0. And when t is equal to 1 over 60, let's see, 1 over 60 times 120, that should give us 2. So our upper limit should be 2 pi. Okay, so we have our limits of integration, we have our substitution, so now let's evaluate this definite integral. 60 times 1 over 120 pi, so that should be 2 over pi times the antiderivative of cosine. So that is the sine function, sine of u, evaluated from 0 to 2 pi. Which would be 2 over pi times, the sine of 2 pi is 0, the sine of 0 is 0, so we have 2 over pi times 0, or just 0. So it looks like, if we go back up, this integral here, which is the average value of this function over the interval 0 to 1 over 60, is 16 over pi. 16 over pi. That's our final answer. And the directions say round this to 3 decimal places. So we could pop this into the calculator. 16 over pi rounded to 3 places will give you 5.093, and that's measured in amperes or amps. Okay, so exact answer 16 over pi or the rounded decimal 5.093. All right, that about does it for this one.